Now let us move on to the third problem. Form the pair of linear equations for the following problems and find their solution by substitution method. And there are 6 substitutions in this. Let's do the first one. First one is difference between two numbers is 26 and one number is 3 times the other. Find them. So we can start like this. First one, let the first number be x, let the second number be y. From the given condition, the difference between two numbers is 26. So from this we can say x minus y equals 26 and let this be equation 1. And one number is 3 times the other, which means we can say x equals 3 times y. Let this be equation 2. Now we can substitute x equals 3y in equation 1. So that will be 3y minus y equals 26, or 2y equals 26, or y equals 26 over 2, or y equals 13. So we have found out one of the numbers. Now we'll substitute y equals 13 in equation 1 and we can find out x. So x minus 13 equals 26, or x equals 26 plus 13. So x equals 39. This is the other number. The two numbers are 39 and 13. So this is our answer. Now let's move on to the second subdivision of the third problem. The larger of two supplementary angles exceeds the smaller by 18 degrees. Find them. So we can start like this. 2. So let the larger angle be x. Let the smaller angle be y. Now the condition is the larger angle exceeds the smaller one by 18 degrees. So we can say x minus y equals 18, or x equals 18 plus y. And so this is equation 1, and we know the sum of the angles must be 180 degrees because it's given two supplementary angles. So x plus y equals 180. So from this, let's substitute x equals 18 plus y in 2. So 18 plus y equals 180, or 2y equals 180 minus 18, that is 162. Therefore y equals 162 over 2, or y equals 81 degrees. So this is one of the angles, and we can find the other angle. So substitute y equals 81 in equation 2. X plus 81 equals 180, or x equals 180 minus 81, that is equal to 99. So therefore the two angles are 99 degrees and 81 degrees. Now let's move on to the third subdivision of the third problem. The coach of a cricket team buys 7 bats and 6 balls for rupees 3,800. Later she buys 3 bats and 5 balls for 1,750. Find the cost of each bat and ball. So this is third one. So we can start like this. Let the cost of one bat equals rupees x, and let the cost of one ball equals rupees y. Now according to the first condition, 7 bats plus 6 balls cost 3800. Similarly, by the second condition, 3 bats plus 5 balls equals 1750. Now we are going to use substitution method. Let this be equation 1, this is equation 2. From 1, 7x equals 3800 minus 6y, or x equals 3800 minus 6y whole divided by 7. Now we'll use this value in equation 2 using x equals 3800 minus 6y whole divided by 7 in equation 2 will give 3 times 3800 minus 6y over 7 plus 5y equals 1750. Now we can simplify this. 11400 minus 18y over 7 plus 5y equals 1750. Now this is, now how did we get this? 3 times 3800 and 3 times 6y. Now we can take LCM. So this will be 7, 11400 minus 18y plus 35y, because 7 into 5 will give 35 equals 1750, and we can cross multiply 7 and 1750. So this is 11400. 35 minus 18 will give 17, so plus 17y equals 12,250. This is 7 times 1750 will give 12,250. 17y equals 12,250 minus 11,400, and that is equal to 850. 17y, therefore y equals 850 over 17, which is equal to 50. Therefore y equals 50. So we are going to use y equals 50 in one of the equations and find the value of x. Now substitute y equals 50 in equation 2. 3x plus 5y equals 1750, or 3x plus 5 times 50 equals 1750. 3x plus 250 equals 1750. 3x equals 1750 minus 250, or 3x equals 1500. Therefore x equals 1500 over 3, which is equal to 500. So we have found out x equals 500. This is the second value. From this we can write cost of each bat equals rupees 500, and cost of each ball equals rupees 50. So this is the answer.